Due to some mechanical disadvantage, our first part of the solution of mock test 5 was terminated at the question number 14. Now in the part 2 we are starting from the question number 15. This is a question from wave theory. The wave described by y equals to 0.25 sine 10 pi x minus twice pi t, where x and y are in meters and t in seconds, is a wave traveling along the positive x direction, the frequency 1 Hz and wavelength 0.2 meter. Next, negative x direction with amplitude 0.25 meter and wavelength 0.2 meter. So what to do? We are to calculate, we are to find the direction of propagation of the wave, its amplitude, its frequency and its wavelength. Now comparing this wave equation with y equals to a sine 2 pi by lambda into x minus vt, we find that a equals to 1/4, and taking 10 pi common, we get it is sine 10 pi into x minus t by 5. Comparing this equation, y equals to a sine 2 pi by lambda into x minus vt, we get that 10 pi equals to 2 pi by lambda. So lambda equals to 2 pi by 10 pi, 1/5 equals to 0.2 meter. Naturally, v equals to, comparison gives v equals to 1/5, that is v equals to 0.2 meter per second. Again v equals to n lambda. V equals to 0.2, lambda is 0.2, so n is 1 Hz. Again, there is a minus sign in between x and t. So this is a wave traveling along positive x direction. So we get that the wave is proceeding along a positive x direction with frequency 1 Hz and wavelength 0.2 meters. This is our correct option. So the correct answer to the question number 15 is A. Now let us consider the question number 16. Two identical piano wires kept under the same tension T have fundamental frequency 600 Hz. The fractional increase in the tension of one of the wires, which will lead of occurrence of 6 beats when both the wires oscillate together, will be. We know that frequency is related with tension, as frequency n is proportional to root over of tension. So in the first case, n is 600 equals to k into root t, where t being the tension. In the second case, frequency is 6 Hz higher, so the frequency is 606 equals to k into root over of t plus delta t, where delta t is the increase in tension. From these two equations, dividing equation 2 by equation 1, we get 606 by 600 equals to k being cancelled out. We get root over 1 plus root over of t plus delta t by t, that is 1 plus delta t by t to the power half. Making binomial expansion, 1 plus half into delta t by t, neglecting higher order terms, we get equals to 600 by 606 by 600 equals to 1 plus 6 by 600. Equals to 1 plus 1 by 100. Again, from simple calculation, we get half of delta t by t equals to 1 by 100. So delta t by t equals to 2 by 100 equals to 0.02. So our correct answer is B. So the correct answer to the question number 16 is B. Now let us consider the next question, that is the question number 17. In question number 17, a uniform rope of length L and mass M1 hangs vertically from a rigid support. A block of mass M2 is attached to the free end of the rope. A transverse pulse of wavelength lambda 1 is produced at the lower end of the rope. The wavelength of the pulse when it reaches the top is lambda 2. We have to the ratio lambda 2 by lambda 1. So we have to find lambda 2 by lambda 1. We know that frequency is the fundamental property, so frequency will remain unchanged. Now, if v be the velocity of the wave, transverse wave, then v equals to root over t by mu, where mu is the linear density, that is the mass per unit length. So, at the lower end, v1 equals to t is m2g, because there only one mass m2 is hanging, so m2g equals to t by mu. For the upper portion, v2 equals to the total weight m1 plus m2 into g by mu. If the wavelength of the wave is lambda 1 at the lower part and at the upper part it were lambda 2, then v1 equals to n lambda 1 and v2 equals to n lambda 2. There is no change in frequency. So dividing equation 2 by equation 1, we get lambda 2 by lambda 1 equals to m1 plus m2 by m2. So D is our correct option. So correct answer to the question number 17 is D. Now switch over to the question number 18. Two cars moving in opposite direction approach each other with speed 22 meter per second and 16.5 meter per second respectively. The driver of the first car blows a horn having a frequency 400 Hz. The frequency heard by the driver of the second car. Now the frequency heard by the second car is very easy. N2 equals to V plus V0 by V minus Vs into N. Both the cars are approaching towards each other. When the source and the observer are approaching towards each other, we know the apparent frequency N2 equals to V plus V0 by V minus Vs into N. Here V0 is 16.5 and Vs is 22. Putting those values here, and V velocity of sound is 340 meter per second, we get V equals to 340, V0 16.5 and Vs as 22. We get 400 into 356.5 by 318 equals to 400 into 1 plus 38.5 by 318 equals to 400 plus 400 into this factor yields 0.12. 400 into 0.12 equals to 48. So the frequency, changed frequency is 448. So the correct option to the question number 18 is C. Now let us consider the question number 19. In question number 19, it is a question from elasticity. If the ratio of lengths, radii and Young's moduli of steel and brass wires are in the figure as A, B and C respectively. Ratio of lengths A, ratio of radii B and Young modulus, ratio of Young modulus is C. Thus the corresponding ratio of increase in their lengths. Increase in length is actually x equals to FL by AY, and A is the cross-sectional area. If the cross-sectional radius is R, then A is pi r square. So x equals to FL by pi r square Y. So x is proportional to F, x is proportional to L, but x is proportional to 1 by r square and x is proportional to 1 by y. So x steel by x bar, brass, x br, brass. For steel, weight acting, actually two weight is acting downward, so the total tension in the steel wire is 3 mg, that is 3 mg, and for the brass wire it is only 2 mg. So the ratio is 3:2. Now the length are in the ratio is A, so length is proportional, so A is we are putting A in the numerator, whereas it is x is proportional to 1 by r square, so B should be put in the denominator and it is in the square form, so B square is in the denominator and x is proportional to 1 by y, so C should be put there. We have to put C in the denominator also, hence the ratio is 3a by 2b square C, and this ratio is found in B. So correct option to the question number 19 is B. Now let us consider the question number 20. In question number 20, we see that the Young modulus of a material of a wire is 2 into 10 to the power 10 Newton per meter square. If the elongation strain is 1%, then the energy stored in the wire per unit volume. Young modulus is given, strain is given, we have to calculate energy stored per unit volume. We know that energy stored per unit volume equals to half into stress into strain, but here Young modulus is given but stress is not given, so stress should be expressed in terms of Young modulus. If we put stress in terms of Young modulus, then stress equals to y into strain, hence energy stored per unit volume equals to half into y into strain square. Here y is 2 into 10 to the power 10, putting it there 2 into 10 to the power 10, and strain is 1%, that is 10 to the power minus 2, and strain square 10 to the minus 2 whole square. So we get 10 to the power 10 into 10 to the power minus 4, that is 10 to the power 6. So a correct option of energy stored in joule per meter cube is 10 to the power 6. We find these 10 to the power 6 in option A. So our correct choice for the question number 20 is A. Now let us consider the question number 21. It is a question from conductivity, thermal conductivity. How much steam of, no, it is a question from calorimetry actually. How much steam of 100 degrees centigrade will just melt 3,200 gram of ice at minus 10 degrees centigrade? Specific heat of ice is 0.5 calorie per gram per degree centigrade. Specific heat of water 1 calorie per gram per degree centigrade. Latent heat of fusion of ice is 80 calorie per gram, and the latent heat of vaporization of water is 540 calorie per gram. Now ice, first temperature of ice rises from minus 10 degrees centigrade to 0 degrees centigrade. So the heat taken by ice is 3,200 into specific heat, it's 0.5 into 10. It is the sensible heat. And now the latent heat. Now that ice of 0 degree centigrade will melt into water at 0 degree centigrade. It will take latent heat, and latent heat required per gram is 80 calories. So for 3,200 gram it is 3,200 into 80. That is the heat taken by the system, and heat released by the steam, which was at 100 degrees centigrade initially. Let M be the mass of the steam required. So it will take per gram steam will give 540 calorie of heat to convert it from 100 degree centigrade steam to 100 degree centigrade water. Now 100 degree centigrade water will convert into 0 degree centigrade water. So each gram will get the sensible heat as MST. M is 1, S is 1, T is 100 degree centigrade. So for M gram, total heat is M into 540 plus 100. So that is equals to M into 640 equals to 3,200. Taking 3,200 common, here is 2 part, 0.5 into 10 equals to 5, and it is 80. So 85. So 3,200 into 85 equals to M into 640. So M equals to 3,200 into 85 by 640. And 5 times 3,200 is 5 times of 640. So the mass required 425 gram. We find this in option A. So the question number 21 having correct option A. Now let us see the question number 22. It is a question from conductivity. The amount of heat conducted per second through a window, inside temperature is 10 degrees centigrade and outside temperature is minus 10 degrees centigrade. That is 1000 joule. So the temperature difference is 10 and minus 10 is 20 degrees centigrade, and heat conducted is 100 joule. Same heat will be conducted in through the window. The outside temperature is minus 23 degrees centigrade. The inside temperature is, when same amount of heat is conducted through same time, then the temperature difference between inside the room and outside is 20 degrees centigrade. Inside temperature is minus 23 degrees centigrade. Outside temperature is minus 23 degrees centigrade. So inside temperature is 20 degrees centigrade higher. That is minus 3 degrees centigrade. That is your 270 Kelvin. So our correct answer is 270 Kelvin. So the correct choice of the question number 22 is C. Now let us see the question number 23. It is also a question from thermal conductivity, which is an important topic for your examination. 3 rods of identical cross-sectional area made from same material. They have same cross-sectional area and they are made of same metal, that is their thermal conductivity is also same. Their conductivity is same. The sides of an isosceles triangle ABC right angled at B. This is the isosceles triangle ABC. And B is the right angle. So AB equals to L. Let AB equals to L, BC equals to L, and AC is L root 2 from the property of right angle triangle. Now, the points A and B maintained at temperature T. A is maintained at temperature T and B is at temperature root 2 T, respectively, in the steady state. Assuming that only heat conduction takes place, temperature of the point C, let it be Tc. Now we know the rate of heat conducted Q by T equals to Ka theta 1 minus theta 2 by D. K is same for all the rods. A is also same. Then temperature difference by length ratio should be same for the steady state when heat conduction through each rod is same. So the temperature difference per unit length, that is temperature gradient, is same for all the rods. For the rod BC, it is temperature difference root 2T minus TC by length L. For CA, it is TC minus T by L root 2. Equating this, L being cancelled out from both sides, we get twice T minus root 2 into TC equals to TC minus T. So thrice T equals to TC into root 2 plus 1. So TC equals to thrice T by root 2 plus 1. So our correct option is A. So the correct choice for the question number 23 is A. Now let us consider the question number 24. It is a question from law of cooling, Newton's law of cooling. A pan pizza cools from 91 degrees centigrade to 79 degrees centigrade in 2 minutes on a summer day, when the room temperature is 25 degrees centigrade. How long will the pan pizza take to cool from 91 degrees centigrade to 79 degrees centigrade on a winter day when the room temperature is 5 degrees centigrade? Now we know that the heat radiated per second, that is Q by T, equals to ms into theta 2 minus theta 1. Let the mass of pizza is m, its specific heat is S, and temperature falls from 91 degrees centigrade to 79 degrees centigrade. That is, the fall in temperature is 12 degrees centigrade. So H equals to MST gives ms into 12 by time taken 2 minutes. So Q by T, rate of heat radiation, equals to K into temperature, average temperature 91 degrees centigrade and 79 degrees centigrade, having average temperature 85 degrees centigrade, 85 minus room temperature 25. For the second case, it is ms into, in the second case, temperature falls through the same limit. So it is 12 temperature difference by T time, let the time taken be T. So ms into 12 by T equals to K into average temperature being same, that is 85, minus room temperature 5. So we get two equations, 1 and 2. And now to get T, divide equation 1 by equation 2, which yields T by 2 for the left hand side, K being cancelled out, we get in the numerator 60 and in the numerator 85 minus 5 equals to 80. So T equals to 2 into 3 by 4, that is 6 by 4, 1.5, that is your 3 by 2 actually. So A is the correct option. So the correct option to the question number 24 is A. Now our question of consideration is now question number 25. The value of coefficient of volume expansion of glycerin is 5 into 10 to the minus 4 per Kelvin. The fractional change in the density of glycerin for a rise of 40 degrees centigrade in its temperature is, we know that the density relation at 0 degrees centigrade, if the density of glycerin is rho 0 and at T degrees centigrade it is rho T, then rho 0 equals to rho T into 1 plus gamma T. Now rho T by rho 0 gives you 1 by 1 plus gamma T. We need the fractional change in density, that is rho T minus rho 0 by rho 0. Rho T minus rho 0, simple mathematical calculation which gives, performing the same operation to the right hand side, we get minus gamma T by 1 plus gamma T. Here gamma is 5 into 10 to the minus 4, T is 40. Putting those values, we get 5 into the minus 4 into 40 divided by 1 plus 5 into 10 to the minus 5 into 40 into 10 to the power minus 4. That is minus 200 into 10 to the minus 4 divided by 1 plus 5 into 40, 200 into 10 to the minus 4, 0.02. So 0.02 by 1.02, which is nearly 0.02. So correct option is D. So the correct answer to the question number 25 is D. Now consider the question number 26. A U-tube with both ends open to the atmosphere, both ends of the U-tube being open to the atmosphere, is partially filled with water. it was partially filled with water and water column being same to both the arms. Oil, which is immiscible with water, is poured into one side until it stands a distance of 10 millimeter above the water level. So we pour oil here and final height of the oil is 10 millimeter above the water height of the right arm. On the other side, meanwhile, the water rises by 65 millimeter from its original level. So, water level from here, it rises by 65 millimeter. So, in the left arm, it will go down by 65 millimeter. So, water level height to the right side with respect to the left arm is 130 millimeter, whereas oil is 10 millimeter higher than the water of the right arm. So the height of the lower oil column is 140 millimeter. Now, at the separating layer, that is the oil and water layer, if we consider the equilibrium condition, then the pressure in this horizontal level is same throughout. At the left side, pressure given by oil equals to 140 into rho into g, P equals to H rho g. And at the right hand side, for the water column, it is 130 into 10 to the power 3 into g, taking water density at 10 to the power 3 kilogram per meter cube. So rho equals to 13 by 14 into 10 to the power 3. That is 0.93 into 10 to the power 3, nearly 930, that is 928 kilogram per meter cube. That is our correct answer of the question number 26. So the correct answer of the question number 26 is C. Now let us consider the question number 27. If the linear momentum is increased by 50%, then kinetic energy will be increased by. We know that. If there is a change in momentum x, then the change in kinetic energy is 2x plus x by 10 whole square. Here x is 50. So 2 into 50 plus 50 by 10 whole square. That is 100 plus 50 by 10, that is 5 square, 25. 100 plus 25 equals to 125%. So the change in kinetic energy is 125%, which we find in question option number C. So our correct choice of the question number 27 is C. Now let us consider the question number 28. A motor drives a body along a straight line with a constant force. Power P developed by the motor must vary with time t as. Here, motor drives a body along a straight line with a constant force, hence force F equals to constant. Now, we have to consider power versus time graph. So, power P equals to F into V, force into velocity. Force is constant here. Now, when force is constant, F equals to ma, mass of the body is also constant, so acceleration will be constant. When a body is moving with constant acceleration, so its velocity at time t, v equals to a into t, where a is the constant acceleration. So power P equals to F into at, F is constant, a is also constant, so a P is proportional to actually implies that P versus T graph should be a straight line passing through the origin. Considering all the graphs, we see that in the first graph, P is proportional to T, that is the straight line passing through the origin. So A is the correct answer. So the correct answer to the question number 28 is A. Now let us see the question number 29. In question number 29, we see a force F acting on a body depends on its displacement. F is proportional to s to the power minus 1/3. The power delivered by F will depend on displacement as. given that f is proportional to s to the power minus 1/3, f is proportional to that. So f equals to k into s to the power minus 1/3. F equals to mv dv ds equals to k into s to the power minus 1/3. So v dv equals to k by m into s to the power minus 1/3 into ds. Integrating we get v square by 2 equals to k by m. It is 2/3 3 by 2 into s to the power 2/3, which gives actually v is proportional to s to the power 1/3. Now power, p equals to f into v. F is proportional to s to the power minus 1/3. V is proportional to s to the power 1/3. So P is proportional to s to the power minus 1/3 plus 1/3, that is s to the power 0. So D is the correct option. So the correct answer to the question number 29 is D. Now let us consider the question number 30. In the question number 30, the potential energy of a 1 kg particle free to move along x-axis is given. The total mechanical energy of the particle is 2 joule. Then the maximum speed. Maximum speed, when the speed is maximum, kinetic energy is maximum. So the potential energy should be minimum in that case. So we are first of all find the minimum value of potential energy. And when the potential energy is minimum, dv dx is 0. So first we are to differentiate the given equation, that is our equation number 1 here, with respect to x. So dv dx gives 1/4 into 4 into x cube minus half into 2x, and this is equals to 0. So x cube, which implies that x cube minus x equals to 0. So x into x plus 1 into x minus 1 so on 0. Either x equals to 0 or x equals to plus minus 1. And it is clear from curve, for x equals to, from the equation we find that for x equals to plus minus 1, potential energy is minimum. So potential energy is minimum, and from equation 1, if we put x equals to plus minus 1, we may find the minimum value of potential energy, because when x equals to 0, it is 0. But when it is either x equals to plus 1 or minus 1, it is 1/4 minus half, that is minus 1/4. That is the minimum value of potential energy. So the minimum value of potential energy is 1/4 minus half equals to minus 1/4. Now total mechanical energy is 2 joule is given. Potential energy is minus 1/4 joule. So 2 equals to minus 1/4 plus kinetic energy half mv square. M is given as 1 kg. So half into 1 into v square, half into 1 into v square. So v square by 2 equals to 2 plus 1/4. That means 9 by 4. That is v square is 9 by 2. So v equals to 3 by root 2. Correct option is B. So the correct option to the question number 30 is B. Now consider the question number 31. In question number 31, we see that a block of mass 0.5 kg is moving with a speed 2 meters per second on a smooth surface. It strikes another mass 1 kg which is at rest, and then move together as a single body. The energy which lost during the collision, we know that the energy lost during the collision equals to half m1 m2 by m1 plus m2 into v1 minus v2 whole square, v1 minus v2 whole square equals to half into m1 is half kg, m2 is 1 kg, put it there, half into 1 by half plus 1, that is 3 by 2 into v1 minus v2. v1 is 2 meters per second, and v2, the second body was at rest, v2 is 0. So the 2 minus, that is 2 minus 0 whole square equals to half into 2/3 into 2 into 2. 2 cancel out, that is 2/3, that is your 0.67 joule. So correct option is C. So the correct answer to the question number 31 is C. Now let us take the question number 32. In question number 32, a spherical ball A of mass 4 kg moving along a straight line strikes another ball B of mass 1 kg at rest. So a ball A of mass 4 kg moving in a straight line, let its velocity be v, so its momentum is 4v. It is striking another ball B, so A is striking another ball B, A having momentum 4v, B having mass 1 kg is at rest. A and B move with velocities v1 and v2 respectively, making angle 30 degree and 60 degree with respect to the original direction of motion of A. Then v1 by v2 equals to A moves at an angle 30 degree with velocity v1. So its momentum is 4v1 and at an angle 30 degree. B moves with velocity v2 having mass 1 kg, so its momentum is v2, 1 into v2 is v2, and it is moving at an angle 60 degree. But initially, if it is x-axis, total momentum was along x-axis. So, momentum along y-axis was 0, and considering the momentum conservation law along y-axis, we may find the ratio of v1 and v2 easily. Now, the momentum component of 4v1 along y-axis here, 4v1 sine 30 degree, and v2 along y-axis is v2 sine 60 degree. Now these two momentums are equal and opposite. That will give us 0 momentum along y-axis. Before collision, momentum along y-axis was also 0. So, following the momentum conservation law, we may at once write down 4v1 sine 30 degree equals to v2 sine 60 degree. So 4v1 sine 30 means half equals to v2 into root 3 by 2. 2 being cancelled out from both sides, we get v1 by v2 equals to root 3 by 4. So the correct ratio is root 3 by 4, and we find it in option number A. So the correct choice for the question 32 is A. Now let us consider the question number 33. In question number 33, we see that it is a question from optics, geometrical optics. Two objects A and B, when placed in turns in front of a concave mirror, give images of equal size. The focal length of concave mirror is 7.5 centimeter and size of object of A is 3 times the size of object of B. The distance of B from the mirror, if A is placed 30 centimeter from it. So the distance F equals to 7.5 centimeter. 7.5 centimeter. So U equals to 30 semi equals to 4F equals to F plus F by 1/3, F plus F by M. So magnification is 1/3 here. And A was 3 times in size and magnification 1/3. So the size of the image of B, is same as that of the object. So in that case, U equals to 2F. When U equals to 2F, V equals to 2F, magnification should be 1. Magnification in case of B is 1 here. So U is 2F, F is 7.5. So the distance of the object in this case is 2F, that is your 15 centimeter. So the distance of B from the mirror is 15 centimeter. So our correct choice for the question number 33 is B. Now let us consider the question number 34. It is a question from refraction. A light beam is traveling from region 1 to region 4. The refractive indexes in regions 1, 2, 3, 4 are mu0 by 2, mu0 by 6 and mu0 by 8. The angle of incidence theta for which the beam just misses entering 4. Just misses entering means it goes critically. That is, the angle of refraction is 90 degree here. And for such parallel medium, we may write down as Snell's law, mu0 into sine theta equals to mu0 by 8 into angle for the last medium is 90 degree, that is sine 90 degree. Mu0 being cancelled out, sine theta, sine 90 is 1, sine theta equals to 1/8, so theta equals to sine inverse 1/8. So our correct choice is B. So correct answer of the question number 34 is B. Now let us consider the question number 35. This question is also from optics. A ray of light falls on a transparent sphere with center C. This is a sphere of center C. Ray of light is falling at an angle 60 degree. The ray emerges from the sphere parallel to the line AB. After refraction, it emerges of the sphere parallel to AB. Just it falls here and it goes parallel to AB. Just parallel to AB. Let us, this is the point P. P is the point of emergence from the sphere, and to consider the problem, we add P with C because this is the normal at the point P. Now, angle of refraction here is I, and ACP is an isosceles triangle because AC is the radius of the sphere and CP is the radius of the sphere. If CAP angle is I, then APC is also I. And from the reversibility of light, the angle in air is 60 degree, angle in glass is I, angle within the sphere is I. So when angle of incidence in the glass is I, then the angle of emergence should be 60 degree. From reversibility of light, from the theory of reversibility of light, we may at once come to this point. Also that this is the exterior angle and it is equals to, for this angle, for this triangle ACP, this is the exterior angle, it is equals to I plus I, that is twice I. Again, CB and PT are parallel. So, if this angle is twice I, PCB, then PCB equals to 60 degree. 60 degree, so twice I equals to 60 degree, so I equals to 30 degree. We need the refractive index of the sphere. Now, for the refraction at the point A, we may at once write down from Snell's law, sine 60 degree, 1 into sine 60 degree equals to mu into sine 30 degree. So, root 3 by 2 equals to mu into half. 2 being cancelled out, mu equals to root 3. So, our correct option here is C, mu equals to root 3. So, the correct answer to the question number 35 is C. Now, let us take the question number 36. In question number 36, we see that it is a question from refraction of light. Light travels in two media A and B with speeds 1.8 into 10 to the power 8 meter per second and 2.4 into 10 to the power 8 meter per second. Then the critical angle. So, first one is the denser medium, second one is the rarer medium, and this angle is theta c and this angle is 90 degree. Velocity of light in the first medium is 1.8 into 10 to the power 8 meter per second. In the second medium, in the rarer medium, the velocity is much greater than that of the denser one. So, from Snell's law, mu means mu equals to C by V. C by V 1.8 into 10 to the power 8 into sine theta c equals to C by V here 2.4 into 10 to the power 8 into sine 90 degree. So, C being cancelled out, sine theta c equals to what? Sin theta c equals to 1.8 into 10 to the power 8 by 2.4 into 10 to the power 8. Sin 90 being 1, 10 to the power 8 being cancelled out. This is 3 over 4. Sin theta c equals to 3 over 4. So theta c equals to sin inverse 3 by 4. So D is our correct choice. So the correct option to the question number 36 is D. Now let us take the question number 37. In question number 37, a point object is placed at the center of a glass sphere of radius 6 semi and refractive index 1.5. The distance of the virtual image from the sphere's surface of the sphere is, here is a sphere. A point object is placed at the center of the sphere, C being the center of the sphere. A point object is placed there. Refractive index of the medium is 1.5. The distance of the virtual image, when the object is situated at the center, or point object is situated at the center, all the rays coming out will be normal to the surface. So there is no deviation. So if you put your eye here, you will see all that rays will coming from the source. So virtual image will be formed at C. So distance from the surface to C is the radius of the sphere, and the distance of the image is also 6 centimeters. So our correct choice is C. So correct answer of the question number 37 is C. Now let us take the question number 38. The size of the image of an object which is at infinity as formed by a convex lens of focal length 30 semi is 2 centimeter. Object is at infinity. Image formed by convex lens. Here is a convex lens. Object is at infinity. So parallel rays are falling on the lens and they are meeting at the focal point having height 2 centimeter, or focal point having height 2 centimeter. If a concave lens of focal length 20 semi is placed in between the convex lens and the image is formed at 30 centimeter, that is at the focal plane. A concave lens is placed in between the image and the convex lens O and I at a distance 26 centimeter. So converging rays are incident on the concave lens, and point of convergence, that is the object distance, is 4 centimeter. Object distance U is 4 centimeter. U is 4 centimeter, and it is in the direction of light. U equals to 4 centimeter. Now focal length of the lens, concave lens having focal length 20 semi. So focal length F equals to minus 20 centimeter. The new size of the image, to find the size of the image, we first of all we need to calculate the image distance. We know that 1 by V equals to 1 by F minus plus 1 by U, that is 1/4 minus 1 by 20, that is your 25 minus 1. So V equals to 20 by 4, that is your 5 centimeters. So the magnification V by U, that is your 5 by 4, is 1.25. Magnification equals to height of the image by height of the object is here. For the concave lens, height of the object is 2 centimeters. So I is 2 into 1.25, that is 2.5 centimeter. B is the correct answer. So the correct option of the question number 38 is B. Now let us consider the question number 39. In question number 39, a ray of light passes through an equilateral prism such that the angle of incidence equals to the angle of emergence. Latter equals to 3/4 the angle of the prism, the angle of deviation. We know that angle of deviation equals to delta equals to I1 plus I2 minus A. Delta equals to I1 plus I2 minus A. And by the given condition, I1 equals to I2 and latter is equals to 3/4 the angle of the prism. This is equals to 3/4 A. So delta, we have to calculate delta, angle of deviation. I1 3/4 A, I2 is also 3/4 A, minus A, 3/4 plus 3/4, 3/2, 3/2 A minus A, that is your A by 2, A by 2. Here A is what? It is an equilateral prism. So A is 60 degree. So delta equals to A by 2 equals to 60 degree by 2 equals to 30 degree. So our correct answer is 30 degree. We find it in option number D. So the correct choice of the question number 39 is D. Next question is question number 40. In question number 40, when a telescope is in normal adjustment, the distance of the objective and the eyepiece is found to be 100 centimeter. If the magnifying power of the telescope at normal adjustment is 24, so the magnifying power AM equals to F0 by FE equals to 24. So F0 equals to 24 FE. And distance is 100 centimeter in between the two lenses, that is your objective and eyepiece. That is F0 plus FE for normal adjustment. This is 100. Again F0 is 24 FE. So 24 FE plus FE equals to 100. So 25 FE equals to 100. Hence FE equals to 100 over 25. That is your 4 centimeter. So FE is 4 centimeter. F0 is 24 times FE, that is 96 centimeter. So F0 96 centimeter, FE 4 centimeter. We find it in option number A. So our correct choice of the question number 40 is A. Now let us consider the question number 41. In question number 41, two identical glass equiconvex lenses of focal length F are kept in contact. The space between the two lenses is filled with water. The focal length of the combination is such that there are two back-to-back lenses and the space in between them is actually filled with water. So we have back-to-back 3 lenses and we have to calculate the focal length of the combination. First one convex, third one convex, and the middle one is concave one. So we have to find the focal length of the concave lens. Now, the identical equiconvex lens of focal length F. So, for the equiconvex lens, 1 by F equals to mu minus 1 into, being identical, 1 by R plus 1 by R, that is your 2 by R. Mu is 3 by 2, mu G, that is 3 by 2 minus 1 into 2 by R, half into 2 by R, means 1 by R. So F equals to R. F equals to R, first of all. Next, for the concave one, what to do? 1 by F equals to minus mu minus 1, mu here 4 by 3, because it is made of water. 4 by 3 minus 1 into 2 by R. That is your minus 1/3 into 2 by R minus 2 by 3R. 1 by F equals to. So for the whole combination, 1 by F equals to 1 by R plus 1 by R minus 2 by 3R. That is your 3R. Here R equals to F also. 3 plus 3 minus 2. So F equals to, capital F equals to 3R by 4, that is your 3F by 4. So our correct option is D. So for the question number 41, we find that D is the correct choice. Now let us take the question number 42. In question number 42, we find that a point object is placed at a distance of 12 centimeter on the axis of a convex lens of focal length 10 semi. On the other side of the lens, a convex mirror is placed at a distance 10 centimeter from the lens. So, first of all, we have a convex lens of focal length 10 centimeter, F equals to 10 centimeter, an object Point object is at the distance 12 centimeter. So first of all, 12 equals to 10 plus 2. That is your 10 plus 10 by 5. So our magnification is 5 here. So image distance V equals to 60 centimeter. Image distance V equals to 60 centimeter. V equals to 60 centimeter. In the passage, a convex mirror is placed at a distance 10 centimeter from the lens. From 10 centimeter from the lens, a concave mirror is placed. When concave mirror is placed, what happened? The image is formed by the combination coincides with the object. So there is a path reversal of the rays. So the rays are falling on the concave mirror normally. So they should meet at the center. Total distance is 60 centimeter. The distance between the lens and mirror is 10 centimeter. Hence, this point of meeting the rays is 50 centimeter away from the pole of the convex mirror. Hence, the radius of curvature of the convex mirror is 50 centimeter because the rays are falling normally to it. We have to find the focal length of the mirror. So F equals to R by 2, which gives us the focal length of the convex mirror is 25 centimeter. So the focal length of the convex mirror is 25 centimeter. We find it in option A. So the answer of the question number 42 is A. Now let us take the question number 43. We see it as a problem from prism. If one face of a prism of angle 30 degree and mu root 3 is silvered, the incident ray retraces its initial path. The angle of incidence is. Here is a prism. One of the face is silvered here. Now ray is incident on the other face and optical path is retraced. Incident ray is PQ falling on the point R on the silver surface and retraces its path. So at R the ray is normal to the surface. So the angle of incidence that is on the second surface R2 is 0 degree. We know that A equals to R1 plus R2. If R2 is 0 degree, then A equals to R1. Angle of the prism is 30 degree here. So R1 is 30 degree. The angle of incidence, we have to find the angle of incidence where refractive index of the material of the prism is root 2. So applying Snell's law at the point Q, if the angle of incidence were I1, then sine I1, because here the first medium is here, 1 into sine I1 equals to mu, that is your root 2 into sine R1, that is your 30 degree, equals to root 2 into half, that is your 1 by root 2. Sine I1 equals to 1 by root 2. Then I1 is 45 degrees. So the angle of incidence, required angle of incidence is 45 degree. We find it in option number C. So the correct option for the question number 43 is C. Now let us take the question number 44. In question number 44, it is a problem from human eye. A man's near point is 0.5 meter and far point is 3 meter. Power of spectacle lenses required for reading purposes. For reading purposes, we use the convex lens, so its power should be positive. And for seeing distant object, we use concave lens, its power should be negative. So first one is positive, second one is negative. We find this either B or C is the correct answer here. For the first case, near point is 0.5 meter. So U equals to 50 centimeter. But actual near point should be 25 centimeter. So if U equals to 25 centimeter and V is 50 centimeter, both of them with negative sign because they are in front of these rays are measured opposite to the direction of propagation of light. Here propagation of light is towards right and we are measuring the distance towards left here according to the diagram. So V is minus 50, U is minus 25. So 1 by F equals to 1 by V minus 1 by U, that is your minus 150 plus 1 by 25, 1 by F is 150, 1 by F. So power equals to 100 by F, that is 2 diopter. So first one is 2 diopter with positive sign. Now we have to calculate the second one. To see the distant object with concave lens, the focal length of the lens will be the far point distance. Far point distance is 3 meter. So the focal length of the concave lens is 3 meter. So its power is minus 1/3 diopter, means minus 0.33 diopter. So the correct option is C here. So the correct option to the question number 44 is C. Now let us take the last question for question number 45. In question number 45, a compound microscope has an eyepiece of focal length 10 cm and an objective of focal length 4 cm. Calculate the magnification of an object is kept at a distance of 5 cm from the objective. For the objective lens, focal length is 4 cm. So this is the objective lens, its focal length is 4 cm and object is at a distance 5 cm. So 5 equals to 4 plus 1 equals to 4 plus 4 by 4. So the magnification is 4. For the first case, magnification is 4 and distance is the distance is 5 into 4, 20 centimeter, that is the image distance. So magnification is 4. We have to calculate the magnification in the second case. In the second case, we see that focal length is 10 centimeter. So Fe equals to 10 centimeter. It is also a convex lens. So Fe is positive. And image is formed at the least distance of vision 20 centimeter. So V equals to minus 20 centimeter. So 1 by V minus 1 by U equals to 1 by F. So 1 by U equals to 1 by V minus 1 by F. That is your minus 120 minus 1 by 10. That is your 20 minus 1 minus 2. So U equals to minus 20 by 3 centimeter. Hence, magnification for the second case, that is V by U, equals to minus 20 by minus 20 by 3. So the magnification is 3. For the first case, magnification was 4. Total magnification M equals to M1 into M2. That is 4 into 3. That is your 12. We need what? So the final image is formed at the distance position. Calculate the magnification. That is your total magnification and it is 12. So the correct option to the question number 45 is A. And that is our discussion in the descriptive form. Now let us see the MCQ answer of the whole question paper at a glance. 1C, 2B, 3C, 4B, 5D, 6D, 7A, 8C, 9C, 10B, 11D, 12C, 13C, 14A, 15A, 16B, 17D, 18C, 19B, 20A, 21A, 22C, 23A, 24A, 25D, 26C, 27C, 28A, 29D, 30B, 31C, 32A, 33B, 34B, 35C, 36D, 37C, 38B, 39D, 40A, 41D, 42A, 43C, 44C and 45A. And that is the end of our answers. Now we are interested about the mock test 6. Topic of that exam are laws of motion, work power energy, geometrical optics, kinetic theory, bulk properties of matter, rigid dynamics and gravitation. Expected date of that exam is 14th June. And that's all from my part. Good night to you all.